We know the quadratics, we know the cubics, but we can have any power of x, starting with an x to the power of n, whatever that n power happens to be, and the powers decrease as we go to the right for each term. Remember that you can't have x's on the bottom of any fractions in there. You can't have negative powers of x. You can't have square roots of x. They are normal x's with whole number powers. Okay? So that is what a polynomial is.
So x by itself is a polynomial.
Yeah, so even y equals x, which we know is a straight line, is a type of polynomial, correct?
Because x is to the power of 1.
Yep.
So x
It's still a
equals x is
polynomial.
a polynomial.
Y equals x, yes.
So y equals 1 over x is not a polynomial.
Correct. Now guys, I appreciate the questions, but in this booklet, there is going to be times when we're going to be pushed to get through the examples, so let's try to minimize distractions as much as possible, okay? So there's a few words we need to know for this topic. Let's go through them. You've heard of this one before, coefficient. The coefficient is the constant in front of a pronumeral. So if I was looking for the coefficient of the x squared in this expression here, I find the x squared and it's the number in front of it, which, because it's just a minus sign, would be a minus 1. Okay, you've done that many times before. The degree of a polynomial is the value of the highest power. Usually it's the first term that you see, but not always. So in the polynomial that you see here, 2x cubed minus x squared plus 5, the highest power of x there is 3, so we would call that a degree 3 polynomial. The leading term is also the term that has the highest power. It is usually in that first position, which is why we call it the leading term, but again, not always. So again, using that same example, the 2x cubed is the leading term. A constant term is any term that has no variable, which means no pronumeral in it. So that would be the 5 in that example there. It does say there the definition of a polynomial above is a0 is the constant term. So that was up here, the a0 on the end of this general expression up here. That a0, because it doesn't have an x with it, would be the constant term. Those a's are just standing for the different coefficients of all those different x's up there. The leading coefficient, well, if coefficient means the number in front of, the leading coefficient is going to be the coefficient of that leading term, which for that one we were using would be the 2. A monic polynomial is a polynomial that has a leading coefficient of 1. We've seen that in our monic quadratics that we were trying to solve, so we've heard that word before. So monic just means that it's a coefficient of 1. For our leading term. The roots. The roots are the solutions. Alright, not for us. The roots are the solutions of an equation. So when we were doing parabolas, it was the x-intercepts. So for polynomials, there's going to be quite a few of them in some of the questions. So all the x-intercepts are the solutions or the roots. All those words you're going to be hearing, they all mean the same thing. Here comes Logan, he's made it. He's got to sign in. And zeros. Zeros are those values of x which make the polynomial equal to 0. Note the subtle difference between the roots and the zeros. Okay, some names of polynomials. Polynomials of low degrees have standard names. We've mentioned a couple of them already. But this one, you can actually have a 0 polynomial. It doesn't happen very often because it doesn't do much. That's just where your polynomial is equal to 0. It would just be y equals 0. They've just called it z of x, because remember that's function notation, but they've called it z because it's 0 function. 0 function of x is equal to 0. This is a special case because it has a constant term of 0, but with no term, with a non-zero coefficient, there is no leading term. Okay, there is no leading coefficient and there is no degree. It is quite exceptional in that its graph is the x-axis and that every real number is a 0 because every single spot along that is a solution, isn't it?
Just a dot then, or is it like?
It's just a line going on the x-axis. Yeah. All right, next. A constant polynomial is a polynomial whose only term is a constant. So for example, let's make one up there. I could do p of x is equal to 5. So no letters at all. My polynomial just is a constant number. It would be the same as saying y equals 5, so it'd be going through the y-axis horizontally. Remember, you don't always have to use the p. You will be using different letters. You could also have fractions and minus signs in there as well. They would all be examples of a constant polynomial. Apart from the 0 polynomial, all constant polynomials have a degree of 0, but no zeros. No zeros meaning they're not going to intersect that x-axis because they're either above or below, aren't they? They're horizontal lines, because remember it said excluding the 0 polynomial. All right, and they're equal to their leading coefficient. Next type is a linear polynomial, which means our straight lines. These are polynomials of degree 1. So something like p of x or y equals 2x minus 3. Okay, we're used to seeing those kinds of equations. We can identify that as a straight line, and we could read off the leading term and leading coefficient, which would be 2, and the constant term, which would be minus 3. Okay, next page. A polynomial of degree 2 is, of course, our quadratic. Okay, let's make up an example there. It says, for example, let's make one up. P of x equals anything with an x squared in it.
X squared plus x squared 3x.
I'm already ahead of you.
Plus
Give me a
2.
constant. Plus 2, okay. So it could be whatever. Okay, so anything that has an x squared in it is going to be a quadratic because that's the highest power of x. And then I have decreasing powers from there. Polynomials of higher degrees are called, so a degree 3, we probably know the name of that one, a cubic, good. So a cubic for degree 3. What about a degree 4? Is the booklet here for you? 40. Yeah, good. And all right, degree 5. What do you call it when someone has 5 babies? Quintuplets, so it's quintics. Now, you're not going to get tested on that. We just tend to call them a degree 5 or a degree 4 polynomial, but still interesting to know. So, things that we're going to be doing today, like this here, this next part, we want to be doing addition and subtraction of some polynomials. So any two polynomials can be added or subtracted, and the results are again going to be a polynomial. So if I want to add, for example, 4x cubed plus 9x minus 3 with 5x to the power of 4 minus 6x cubed plus 2x squared plus 1. The brackets in there, because I'm adding them, they're only brackets around there because that's identifying the two different polynomials that we're adding. We don't really need them. All I need to do is collect the like terms. Start with the highest power and work your way down. So the highest power is x to the power of 4. There is only one of them. So I don't have to add it. It's going to be 5x to the power of 4. That's that one done. Next highest power would be the x cubes. So I have 4x cubed minus 6x cubed, which is minus 2x cubed. So those ones are done. Next highest power would be the squared, which there's only one of those. It's a 2x squared. Done, cross it off. Looking for x's now. I have just that 9x, so plus 9x. And that just leaves our x to the power of 0 terms, otherwise known as our constants. Minus 3 plus 1 is minus 2. So that's it, how easy it is, just adding two polynomials together. Next thing it says there, the 0 polynomial is 0 for addition. It makes common sense that if I was adding, just changing my highlighter there, if I was doing any polynomial plus a 0 polynomial, it's just going to be that original polynomial, because I'm adding nothing, I'm adding 0. In case it's just a little property there to keep in mind. The opposite polynomial. So if p of x was my starting polynomial, the opposite would be minus p of x. So if any polynomial p of x is obtained by taking the opposite of every coefficient, that would mean that the sum of p of x and minus p of x should be 0. Okay, makes sense, doesn't it? Let's just do it here. For example, it says, if my first polynomial is 5x to the power of 4 minus 6x cubed plus 2x plus 1, and I want to add to that the opposite polynomial. So I'm going to go through and change all the coefficients of that original one. So it would be minus 5x to the power of 4. The minus 6 become a plus 6x to the power of 3. The plus 2 becomes a minus 2x squared, and they become a minus 1 there on the end. So obviously 5x to the 4 minus 5x to the 4, everything's going to cancel out, and it comes out as 0. So if you add a polynomial to its opposite, you will get 0. The degree of the sum or difference of two polynomials is usually, and it does say there usually, the maximum of the degrees of the two polynomials. So if I look back to this top one that I did up here, when I was adding those two polynomials, this one was a degree 3 polynomial and this one was a degree 4 polynomial. So when I add them together, the polynomial that I get is going to have that same highest degree there, is what that means. Now it does say usually. What would be the exception to that? It would be if that highest power cancelled out. So if I had a 5x to the power of 4 and a minus 5x to the power of 4, then that is going to change because my highest degree is going to cancel out. Okay, but usually. So we have a little summary box there. Let p of x and q of x be non-zero polynomials of degree n and m respectively. If n is not equal to m, then the p of x plus q of x, adding those two polynomials together, is going to be the maximum degree out of either m or n. Whichever one is bigger is going to be your maximum degree, your highest degree. If n is equal to m, then when you add those two polynomials together, it says that you would get less than or equal to, because that is when they could cancel out. And so the degree could potentially be less. So it could still be whatever the highest degree is, but it could be less if they cancel out. And there is the possibility that if they were opposite polynomials, they would cancel out, everything would cancel out, and we would get 0, which is this last case here. P of x plus q of x could potentially equal 0 if they were opposite polynomials. Okay, it all makes more sense when you do these questions. All right, adding and subtracting done, we now want to look at multiplying. Any two polynomials can be multiplied to give another polynomial. For example, we want to multiply 4x cubed plus 9x minus 3 with 5x to the power of 4 minus 6x cubed plus 2x squared plus 1. That was a mouthful, wasn't it? So we expand that, and unfortunately that is a lot of terms to expand, because the 4x cubed has to multiply by everything in that second bracket, and then I need to do the 9x by everything in that second bracket, and then the 3 by everything in that second bracket. So let's give it a go. Be very careful. If you mess up one little multiplication in there, it changes your whole answer. So 4 times 5 is going to be, I'm going to start right up on the left-hand side because this is going to be a long expansion. 4 times 5 is 20, and x cubed times x to the 4 is going to make x to the power of 7. 4 times minus 6 is going to make minus 24, x to the power of 6. 4 times 2 makes 8, x to the power of 5. 4 times 1 makes 4x cubed. That is just the 4 done. Now moving on to the 9x and multiplying the 9x by each term. 9 times 5 is 45x to the power of 5. 9 times 6 is 54, x to the power of, thank you, got to have that minus sign, don't I? X to the power of 4, and 9 times 2 is 18, x cubed, and 9 times 1 is 9x. And finally, the minus 3. Minus 3 times 5, minus 15, x to the power of 4. Minus 3 times minus 6 makes a plus 18, x to the power of 3. Minus 3, yeah, sure. Minus 3 times, what was I up to, the 2? Minus 6x squared, and minus 3 times 1 is minus 3. Yes, I'm just making sure I didn't miss one there with the little interruption. Yep, everyone got the same thing? Good, all right. Is there anything we can collect up?
No.
There is. Okay, so starting with the highest power, 20x to the 7. There is no other x to the 7, so that one doesn't change. X to the power of 6, there's also none others of those, so 24x to the 6. Sometimes you can cross off the ones you've dealt with, so that makes it less confusing. X to the power of 5, yeah, there's 2 of those. There's 8x to the 5 and 45x to the 5. So that makes 53. Plus 53, x to the power of 5. So those ones are done. X to the power of 4. We have 4, do we have any more? Yes. We have minus 54, and then we have minus 15. So that's minus 69. X to the power of 4. X cubes. I have 4x cubed, 18x cubed, and another 18x cubed. 4 plus 18 makes 40. X cubed. On to the squares. Just the 6, the minus 6x squared, only one. Any x's? Yeah, the 9. And constant, the minus 3. So that's a lot more complicated than the adding was. Be very careful, please, if you're multiplying things like that out. Yeah, a little bit. The constant polynomial I of x is equal to 1. So this is called the identity for multiplication in the sense that p of x times I of x is equal to p of x. So saying they're calling I of x is the constant polynomial, not just any constant though, equal to 1. So any polynomial times by 1 is going to be equal to the original polynomial. So another property in there. Multiplying by 0 is always going to give you 0 as well. That's the next one. If two polynomials are non-zero, then the degree of their product is the sum of their degrees. So that's summarized in here in this next box. P of x and Q of x, if they're non-zero polynomials, when I multiply them, it will be the degree of P of x plus the degree of Q of x. The one that I just did, my first polynomial was a degree 3, and my second polynomial was a degree 4. 3 plus 4 is 7, and my answer was a degree 7 polynomial. So that's what that's saying. The highest power of x. Okay, so here most of that was really just theory. here is some of the examples like the ones you're going to see in your textbook. If a of x equals x squared plus 2x plus 3, and b of x equals 2x minus 5, and c of x equals that one, and we have all these different polynomials, okay? It wants me to find a of x plus c of x, so we're adding. So write down the polynomials that you're adding. So a of x first was x squared plus 2x plus 3. Okay, you can put it in brackets if you want to, but you don't need them for adding. And then I want to add to that c of x, which is 3x to the power of 4 minus 3x squared plus 5x plus 6. Okay, and collect up your like terms, starting with the highest power. So 3x to the power of 4 is the highest power. Looking for an x cubed, but I don't have one. So then I move on to x squared. So I have 1 minus 3, which is negative 2x squared. Then on to x terms. I have 2 plus 5 makes 7x. And constants, 3 plus 6 is 9. Easy enough, right? Okay, part B. We want to multiply b of x, so let's write that down. We're multiplying, so I am going to need brackets. B of x is 2x minus 5, and d of x is x to the power of 5 minus 3x squared plus 1. And I need to just expand that out. So 2x times x to the 5 is 2x to the power of 6. 2x times minus 3 is going to be minus 6x cubed. 2x times 1 is 2x. Now multiplying the minus 5 through. Minus 5x to the 5 plus 15x squared and minus 5. Looking for things to collect. Highest power is 2x to the 6. X to the power of 5, I only have one of those, so minus 5x to the power of 5. X to the power of 4, there isn't one, so x to the power of 3 will be minus 6x to the power of 3. X to the power of 2, none of them are being collected, but I'm just rewriting them all in the right order. So 15x squared, then I have a 2x and a minus 5. Okay? How are we going for time? 1:15. Don't worry, we're going to run out of time here.
Yeah, we'll double period.
Oh, we do have a double. Of course, we're fine then. All right. Question C. D of x is, write it down. So D of x was x to the power of 5 minus 3x squared plus 1 minus c of x. Now, you can do this in one step or you can do it in two. If you are subtracting, that has to expand through the whole second polynomial. Can we do it in one step? Is that all right? Yeah. Expand the minus through. So minus c of x will be minus 3x to the 4 plus 3x squared minus 5x and minus 6. And then collecting up. Starting with the highest power, x to the power of 5. Then there's minus 3x to the power of 4. X cubed, there isn't one. X squared, we have minus 3x squared plus 3x squared, so they cancel out. Then on to x's, I just have minus 5x. And constant 1 minus 6 is minus 5. Sorry?
There's a lot of 5s in there.
There was. Okay, question D. We want to multiply a of x times d of x. So a of x is x squared plus 2x plus 3. And we're timesing that with d of x, which is x to the power of 5 minus 3x squared plus 1. I think we've done a few of these now, so I'm going to just be quiet here and let you try expand that. Have a go. All right, did we get the same thing? It's easy to do. It's very easy to do.
I thought minus 9 plus 7 was minus 7.
Oh, okay. All right.
Yeah.
Almost done? Got it?
Yeah.
All right, and one more of these. This has got quite a few things involved. We want to do a of x, which is x squared plus 2x plus 3. 2c of x means we want to times 2 by the c of x function, which was 3x to the 4 minus 3x squared plus 5x plus 6. And then minus 3 lots of the b of x, which is 2x minus 5. So then we just have to expand it out and collect everything up. Just expand it, just a small little job to do. It's easier than the last one because we're just timesing by 2 for the first bracket, so that's 6x to the 4 minus 6x squared plus 10x plus 12, and then the next one timesing minus 3 in, so minus 6x plus 15. And then collecting up, starting with the highest power. So the highest power is the x to the 4, so 6x to the 4. Looking for x cubes, don't have any. X squareds, 2 minus 6, so 1, sorry, minus 6 is minus 5. X squared. Looking for x's, we've got 2 plus 10, which is 12, minus 6 is plus 6x. And the constants, 3 plus 12 is 15, plus another 15 makes 30. That was a bit of fun, wasn't it? Look at us go. Okay, so the next thing we're going to have to do is talking about identically equal polynomials. If two polynomials, p of x and q of x, are identically equal, you will possibly see the congruence sign being used. P of x is congruent, it says, which means identically equal in every way to q of x. Now, usually in these kinds of questions, you're going to be trying to find some unknowns. You're actually going to be solving like an A, B, or C. And what you do is you equate the coefficients that have the same powers of x. And that's our next question here. So example 2. It says find A, B, C, and D if we have this lovely big equation here. Okay, so in order to do that, I'm going to need to expand out that bracket on the right. So I'm just going to do that straight underneath here using the short method. 2x squared times 2x squared makes 4x to the power of 4. Don't forget your middle terms. 2x squared times minus 5 is minus 10, and we double it to be minus 20x squared. And then, yes, the middle part. Double the two middle ones times, double the 2 times together.
Oh, that's triangle.
And then minus 5 times itself makes plus 25. So then what we do is we have a look on the left-hand side of the equation at the x to the power of 4s. Okay, so I often write, I'm going to look at the x to the power of 4s like this. On the left-hand side, I have a coefficient of a. And on the right-hand side, in front of that x to the power of 4 is a 4. So that means a is equal to 4. Done already. Then let's have a look at our next power. Let's look at our x cubes. On the left-hand side, it is a b. And on the right-hand side, where's my x cubed? There isn't one, which means it would be 0. Correct. Let's look at our x squareds. On the left-hand side, we have a c, and on the right-hand side, it's minus 20. And x's, x to the power of 1s we call them. On the left-hand side, it's d. And on the right-hand side, do I have any? Nope, so 0 again. And the constants we call x to the power of 0. On the left side, it's e, and on the right side, it's equal to 25. Now that one comes out really easily. There are some harder versions of this where you have to solve simultaneous equations to get answers to come out of that. Oh, that was fun? Oh, good. Okay, factoring, and we're going to spend a fair bit of time trying to factorize polynomials. This one is, okay, I'll read it. A significant aspect of this chapter is being able to factorize polynomials. By expansion, we can see that x squared minus 1 times x plus 3 times x minus 2 is going to be equal to that. And there's a space there so that we can show it. Okay? Because it's actually kind of fun to expand out lots of brackets. Don't you think? Yeah? All right, so let's start with the left-hand side. And we're going to expand. So I'm going to leave the first bracket, the x squared minus 1, and I'm going to expand the next two brackets. X times x is x squared. X times minus 2 is minus 2x. 3 times x is 3x. And 3 times minus 2 is minus 6. Now, I am going to expand again, but I want to collect up my middle terms there first. So x squared plus x minus 6, just to simplify that. Now we have two brackets again that we're going to expand again. So the x squared times by everything in that second bracket makes x to the power of 4 plus x cubed minus 6x squared. Now the minus 1 times by everything in the second bracket, minus x squared minus x and plus 6. Okay, so that's all you do. If you have more than two brackets to expand, you just do them two at a time. Expand two out, simplify them, expand the next one out, and keep simplifying. Do I have some terms to collect in there? Yes, I do. X to the power of 4 plus x cubed. The minus 6x squared minus another 1 will be minus 7x squared minus x plus 6. Okay? However, it is not always obvious how to move in the other way. If I give you the expanded polynomial that we just got there, how do we get back into that factorized form? And we're going to spend a lot of time practicing that. If p of x is a polynomial, then p of x equals 0, it makes it an equation that we can solve. Solving polynomial equation is closely related to factoring that polynomial. We have to be able to factorize it. If p of x equals x to the power of 4 plus x cubed minus 7x squared minus x plus 6, then completing the factorization above will give the solutions to that quadratic. Okay, so we have to solve it, to find the zeros, we have to have it factorized. So we already knew. I'm not asking you to do that yet. We already knew that the factorized form was, now there is an extra step there. I had x squared minus 1, but that has been factorized further to be, because that's a difference of two squares. Whoops, that was meant to be the highlighter. Come on, highlighter. X squared minus 1, x minus 1, x plus 1 is the same as x squared minus 1, isn't it? Okay, so factorize that first bracket again. See this bracket up here? Just factorize that bracket even further. And then we have the x plus 3 and the x minus 2. So with that polynomial completely factorized, then we can read off our solutions or our zeros, right? And it's just the opposite of those numbers that are in that bracket. So the solutions for that one is going to be positive 1 for that first bracket, negative 1 for the second bracket, negative 3, and a positive 2. So there are going to be 4 intercepts. Yeah, it's going to make a nice little wave going through 4 intercepts on that x-axis. The solutions to the polynomial are called the roots. So we call these the roots. So get used to that terminology. And that's what you're practicing in 10A.